Hey everyone, what I'm trying to do here is trying to give an example for a 3D frame, and I'm trying to kind of explain what is the local coordinates versus global coordinates, because it's pretty important. So we start by doing a grid. Yeah, just for illustration, we'll just do 1 feet, 1 feet, 1 feet grid of let's do 8 by 8 and by 6, something like that. Okay, then that's our grid. So I want to kind of do a house or something similar, so I will switch to XZ plane for now, because this is like XY plane is like a plan view. I don't want that, I want this one. Then the definition, materials, we already have steel in there, I'll just stick with that. Then for the section properties, we'll just do a steel cross section, and let's do an eye. Then there's some, SAIC 13 sections. So how about we just go with something like a 12 by 40, something like that. I don't know. Yeah, probably not 12 by 40, but something smaller. 6 by 12. Okay, here we go. And now here it actually gives you the local 1, 2, 3. Local 1 is actually going into the plane. Going out of the plane, out of the screen, because the right hand rule, 1 to 2, your sum should point to 3. So the 3 is actually a strong axis, the 2 is the weak axis, and the 1 axis is just along your beam member. Okay, then that's good. We have that section here. So now we need to draw our frame. So here the release, you don't do pinned, okay, you just do continuous, so that it is a frame. So we just go from here, 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 here. Okay, now that's that. And then now what I want to do is that I want to kind of copy this guy. So I'll select all, edit, move, no, not move, but replicate, linear. So D, you see here it's like X, Y, Z. So we're gonna go to the Y. Let's do maybe 4 feet, or we can do better than that, maybe 5 feet, so it's 60 inches. It's negative because the Y is in that direction. We got that. Then what I want to do is I want to connect those two and then add something similar to like a rafter here in the middle, but I cannot do that because there's no point in the middle. So I'll get rid of this snap, and then I'll select those 4 frame members, and then I'll edit lines and divide frame. Divide into specific number of frames. I divide into 2 parts, and the ratio from the first and last is 1, so equally divide them into 2 parts. Now it's divided. You cannot see it, but if you do the shrink, you can see this actually becomes 2 elements. Now I will slap to the lines and edges, and then I will draw my member. So it's kind of okay. I know what to do it here and here. Okay. Now I finished drawing all my members. You can actually see. It something like that. And now I need to add my boundary conditions, so I just simply want to kind of fix those guys. At the base, assign joint resistance 4. Okay. Now we add some load. Let me just add a load here. Joint loads, force. Just be kind of creative. Maybe like a 20k there, and then 15k here, and then it's negative 35, something like that. Okay, so I just add some random things, and then I will just do analysis. 3Dframe. Yep. And you see, I mean, the forces are not transferred too much to this end. So if you do something like that, and then this is the moment about strong axis. If you want a moment about weak axis, you can get that too. Scale factor, we'll just do. See, I do 1. Oh no, probably not 1, but maybe 0.1. Well, that looks pretty good, you know. And then you can do axial forces and all that as well. But what I want to talk about here is when you're doing a frame, you have to kind of control the orientation of your frame. What does that mean? That means if we do the extruded view of our frame, you see, this is kind of weird, but anyway, this will work. You see, this is not exactly what we want. For example, those two, they have the flanges facing this way. What about this is actually pretty realistic, but I mean, in some occasions, what about I wanted the frames to face this way, and especially for this guy, you know, if you look at the XZ and and then let me just rotate it a little bit. Oh, it won't allow me to rotate. Okay, 3D. But anyway, you can see it from like this corner. Let me try to see if I can get it into the OpenGL. Okay. Oh, okay. Yeah, this is much better. Oh, now you can see. I mean, how many times do you see a actual design that will have a beam configuration like this? Typically, this one should be kind of rotated so that you got a flat surface at this slope, and so this one needs to be kind of rotated. But the question is how we do that. We know how to do that because we talk about the angle rho. So, but where do we specify that? So you specify that by kind of right click on it, and then there is a rotation angle somewhere. Oh, local axis. Okay, local axis, if you click on it, it doesn't really tell you much, but this is exactly what we talk about in class. This one is oriented so that it's 1, 2 local axis is formed a vertical plane. But now what we want is that for this vertical plane to rotate a little bit. We don't know how much. I mean, you can do a calculation to do that, but I just say, yeah, let's rotate like 20 degrees and then see what happens. Okay. You know, the thing is that you can see this one already rotated. but you know, it was not reflected right away. So I think what I need to do is I need to get rid of that and then redo it. Maybe, you know, this should be doing a better job than it. Okay, now you see it's rotated, but I mean, it looks like we're going to the wrong direction. So what we need to do is instead of 20, we'll just go negative 20. Hopefully that'll fix it. And then, you know, yeah, I hate to do this, but seems like that's the only way this will work. Okay, now you see that's kind of what we have in mind. You know, it's not like getting there exactly, but we're close. In fact, I think if we just do oh, what's going on? Yeah, if we just do you can see the difference. Like this guy is kind of completely vertical, and this one already leaning towards it. It's kind of getting it. So if we can just do not 20, but what do you say, 20, 25 maybe, then it should do it. I think so. You know, typically you think hitting F5 gonna be able to do it. Not quite, but you got the idea. I mean, this one, if you really calculate the angle of this slope, you'll be able to kind of just nail it. Just try one more time. Oh, maybe it's just 30. I mean, who knows? I'm being too conservative. Okay. Now, yeah, 30 actually is a little bit shy of 30. Not, I need to rotate a little bit more, like 33 or something like that. But you see now this one is actually pretty good. So for the other side, and you surely see the difference. So what we can do is that we can go to local axis. Then instead of negative 30, we do 33, and then we apply it, and you see this one's actually pretty good, huh? 33 will do it. So this is like the frame. So say if you wanna rotate this the same by like 90 degree, which is probably most of the most often that you do that. So you just do the 90, and then you will find out that it will already be squared off. So extrude view. See, this one's still that because we haven't changed that, but this one already kind of changed the orientation. But I mean, before you do that, how would you know? So there is actually a let me go back to the very basic display. So here's an option in here for the frame. There's a local axis. If you get that, then it doesn't show up here. So typically, yeah, I really hate this. This should be doing a better job than this. So you need to kind of toggle back to that. So now you can see the local axis. You can see for this one, this is the red is always like local axis 1, and then blue is 3, and then white is 2. You can see after kind of rotating, those lined up pretty well with what we want it to be, like for that guy, and for this one. And you can see those are actually different than this one because we rotated it. So this is like a tutorial of a 3D frame analysis and modeling. I think this is extremely important because, I mean, you have to make sure your model represents reality by the ability to be able to kind of rotate those beams to locate them correctly. I think that's yeah, if that's already covered in that tutorial, then that's fine as well. You got more exposure. If not, that's all I want to talk about. I'm still the 3D moment frame. Yeah, of course, for the truss, it doesn't really matter. All right, that's all, and we'll go from there. Thank you.